The James Webb Space Telescope has made a remarkable discovery. Beams of light that appear to radiate from an urban-like area located millions of light years away. This intriguing finding has reignited global interest in the possibility of extraterrestrial life. Turning its focus to Proxima Centauri B, the nearest exoplanet to our solar system, Webb detected unusual, brilliant flashes of light. Could these signals be evidence of an alien civilization? The scientific community is abuzz with speculation. For decades, both scientists and the public have been fascinated by the idea of life beyond Earth. Now, a breakthrough may be at hand. The James Webb Space Telescope has revealed what could be the clearest signs yet. Lights on a distant world that resemble the glow of a city, possibly pointing to the existence of an advanced alien society. This possibility has stirred enormous excitement among researchers, offering hope for the long-awaited discovery of intelligent life. The city-like lights were observed from an astonishing distance of 4 light-years. NASA engineers were left stunned, pondering how long these signals might have been traveling through space, waiting for humanity's technology to catch up. David Kipping, an astronomer at Columbia University, noted that Proxima Centauri B behaves unlike most rocky planets. Rather than simply absorbing sunlight and emitting it as infrared radiation, this exoplanet interacts uniquely with its star, Proxima Centauri, possibly due to atmospheric or structural differences. Webb's discovery underscores its revolutionary capabilities. Its sensitivity to infrared light was critical in detecting the odd behavior of Proxima Centauri B, providing valuable clues about its atmosphere. Researchers now plan to study the planet in even greater detail to determine whether it could support life. What sets the James Webb Space Telescope apart is its ability to detect even the faintest traces of artificial light within a narrow frequency range, much narrower than natural starlight. This makes it especially suited for investigating whether the suspected lights on the planet's night side are real signs of civilization. Proxima Centauri B also has a dynamic relationship with its star, which significantly influences its environment. Much like Earth, it undergoes cycles of day and night as it orbits Proxima Centauri. However, because of its composition, temperature extremes between its day and night sides could be dramatic, scorching hot on one side, freezing on the other, especially if the planet has an atmosphere. These extreme temperature fluctuations are of keen interest to astronomers, as they offer critical clues about the planet's atmospheric structure. With its ability to analyze thermal emissions in infrared, Webb can provide detailed insights into these conditions. Interestingly, the telescope's orbit allows it to align well with Proxima Centauri B's 11.2 Earth-day cycle, making it an excellent tool to monitor changes across the planet's surface and atmosphere over time. If an atmosphere is confirmed, the next step will be to analyze its chemical makeup. Detecting key elements like oxygen, water vapor, or methane would significantly strengthen the case for habitability and possibly life. While the James Webb Space Telescope JWST is exceptionally well suited for analyzing planetary atmospheres, it isn't built to handle every task. It excels at detecting key gases like water vapor, carbon dioxide, and methane, important indicators of possible life, but is less effective at spotting free oxygen, which is a crucial biosignature. Nonetheless, JWST can still identify other important markers, such as ozone, which suggests the presence of a stable, potentially life-supporting atmosphere. As scientists continue to examine the data collected by JWST, the quest to understand distant worlds presses forward. Each discovery brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? It's important to note that JWST can only observe a limited number of exoplanets within relatively close proximity to Earth. For more detailed investigations of planetary atmospheres, astronomers will turn to powerful ground-based observatories like the extremely large telescope YELT, which is scheduled to begin operations in 2027. The YELT is engineered to deliver higher-resolution observations of distant exoplanetary atmospheres, offering more precise insights into their habitability. Anticipation is also building for the next wave of space telescopes. These future instruments will be equipped with advanced technologies designed to reduce interference from starlight, enabling clearer observations of the faint light reflected by exoplanets. Much like shading your eyes from the sun to see more clearly, these systems will block out intense stellar glare, making it easier to study exoplanets' light signatures and assess their potential to host life. However, this is far from a simple task. Stars are incredibly bright and often outshine the dim planets orbiting them, making detection of planetary light extremely difficult. To address this, scientists are developing innovative solutions. One such approach is a coronagraph, an instrument placed inside the telescope to block starlight while allowing a planet's faint light to pass through. By manipulating light waves with precision, coronagraphs can greatly reduce stellar brightness and improve the visibility of surrounding planets. Another promising concept is the star shade, a giant flower-shaped spacecraft that flies thousands of kilometers in front of a telescope. It physically blocks starlight before it enters a telescope, allowing only the light from exoplanets to be observed. This method could be especially effective for studying planets in the habitable zone, where liquid water and possibly life may exist. These advanced technologies demand extreme precision. For example, a star shade must maintain perfect alignment, within fractions of a millimeter, over vast distances. They must also meet the rigorous demands of space missions, including compact size, energy efficiency, and resilience to the harsh environment of space. Despite the challenges, the potential rewards are extraordinary. Successfully observing and analyzing exoplanetary atmospheres could reveal biosignatures, chemical combinations like oxygen, methane, and water vapor in specific ratios that may indicate biological activity. Such a discovery would revolutionize our understanding of life in the universe. Scientists are also exploring ways to directly image exoplanets in much greater detail. Future telescopes may incorporate advanced adaptive optics, which correct distortions caused by atmospheric interference or instrument movement, yielding clearer, sharper images. When combined with starlight blocking technologies, these innovations can enable researchers to not only detect exoplanets, but also map their surfaces and study their climates in depth. This would represent a monumental leap forward in our ability to investigate alien worlds and assess their potential for life. The development of next-generation space telescopes is a critical step in advancing our search for extraterrestrial life by dramatically improving our capacity to observe and understand distant planets. As we continue exploring distant planets, we edge closer to answering one of humanity's most profound questions. Does life exist beyond Earth? This quest is reshaping our understanding of our place in the universe. Space exploration and the search for extraterrestrial life are advancing at an extraordinary pace, with scientists and astronomers diving deeper into the mysteries of faraway exoplanets. The James Webb Space Telescope is at the forefront of this new era of cosmic discovery. Its data is revealing groundbreaking insights into the structure, composition, and possible habitability of distant worlds. Each new finding brings us one step closer to uncovering the truth. The discovery of Proxima Centauri may be just the beginning of a transformative chapter in our pursuit of life beyond Earth.